So the first thing I wanted to talk about, and I call this actually if we could tone the lights down a bit, the sky is falling part of the talk tonight. And you've probably been seeing in the news that the Chinese space station Tiagong-1 is going to crash to Earth sometime in the next several days. The current thinking is it'll be April 1st plus or minus about 18 hours. And it originally was thought to be in December. And so as time goes on, we're getting a little more exact. But I would venture to guess that most of us have not heard much about the Chinese space program. And I wanted to go a little bit into why this mission was very important for them and what was accomplished with it, and then we'll talk about the upcoming re-entry. So as it says, this was the first space station for China. They first started flying taikonauts, is their term for astronauts, back in the early 2000s, and they've been proceeding at a very deliberate pace. They typically are launching crews every 1 to 3 years with very particular tasks in mind to further their expertise, and their ultimate goal is to land people on the moon in the near term being the 2020s sometime. So this was their first big effort to give their taikonauts someplace to go when they launched into orbit. And so this is a view of the Tiagong-1 under construction, gives you a little bit of a feel for the size of it. This is the laboratory module, and then this is the service module. It has propulsion, life support, water, consumables, things like that, and provides stability for the spacecraft. It's about the size of a school bus. So this is pretty similar to what the Russians were launching in the late 1960s. They called those Salyut spacecraft, and we'll talk a little bit more about that as time goes on. So that was the prep, and this is what it looks like in orbit. So here's the laboratory, and then this is the Shenzhou spacecraft, which carries the crew to and from the Tiangong. And actually, the Shenzhou is about equal in size to the laboratory. And so this all started back in 2011. So this was the launch of the Tiangong, and it made it to orbit just fine. They sent up an uncrewed spacecraft, docked with it. They put supplies on board, and so they decided at that point that it was ready for its first crew complement, and so that was going to be the Shenzhou-9 crew, and this is the 3 crewmates. And there were a couple things that were really important about this. First of all, they have a space station. Second of all, it was their first launch of a woman astronaut. And third, it was the first time with a human crew that they would have docked to another spacecraft. And learning how to do the docking is absolutely essential for things like sending people to the moon, because you as we did with Apollo, you need to have multiple pieces. You need to be able to dock them together, and then send that whole new compound spacecraft on its way to the moon. So those were the big firsts. And much like we see with when we launch crews to our International Space Station, it looks very similar. The crews come marching out. This was one of the first ones of these that they actually carried on live television throughout China. So it was very exciting and inspirational for the Chinese population. And here's the crew loaded into the crew module for launch. And this is very similar to the design of the Russian Soyuz, which we're using to carry crews to and from the ISS right now. It's somewhat larger than the Soyuz. And so here was the launch on the 16th of June, 2012. And everything was successful. So 2 days later, the Shenzhou-9 approached the Tiagong and docked. And that, again, is what it looks like as a docked unit. And so the crew spent about 12 days in orbit. They did various experiments on the laboratory module. One of the things that's very different about this compared to the ISS is on the ISS there are what we call habitation modules. That's where the crews eat. They have bedrooms to sleep in. They have toilet facilities. On the Tiagong, none of that exists on the station itself. They have to go back into the Shenzhou spacecraft for all of the the essentials other than oxygen and water. So after the 12 days on board, on the 29th of June, they undocked, and very similar again to the Russian Soyuz, where there's 3 modules. They transfer from the orbital module to the center one, which is the descent module, and then the service module falls away. So it comes down under parachute, and they obviously were very close to where they expected to be, and helicopters were waiting for them. This was the landing in the Gobi Desert. And a closer up view of the spacecraft. Once the recovery crews got there, they popped the hatch and pulled the crew members out, and everybody was in great shape. So that was the first crew on the Tiagong. The second crew was the Shenzhou-10, which happened about a year later, and this included their second female taikonaut. And apparently the way the Chinese system works is they have multiple crews training for the same mission. And then not too long before the launch date, the trainers or the supervisors decide which one of those crews is most ready, and it's sort of like Survivor, I guess. You get put on the spacecraft and launched. And so Wang Yaping was sort of the backup for the first woman astronaut, and she made it on the second mission. So again, this is the launch. On the 11th of June, they docked 2 days later. And one of the distinguishing things of this mission was she actually did things that we've done here at the museum, where we link up to the International Space Station. We have students in the audience. They get to ask questions of the astronaut in space. And so she actually taught a physics lesson to some early college students back on the ground. And when they were ready to undock, they undocked and redocked several times in the course of that one day, just, again, increasing their experience on doing these kinds of maneuvers. And one of the other things, just like sometimes happens here, is the president of China called them and congratulated them. And I think I have another picture here where they're all saluting. The one thing that I noticed in looking at the images of the crews is they don't tend to smile a lot. And the thinking is that it's a cultural thing, that they're very serious about this, and it's not a sort of a jovial time. They're very concentrated on doing the work. So yes, we see very similar activities. The players are somewhat different. So, and then the landing was on the 26th of June in 2013. So that was the two missions that went to Tiagong-1. It stayed in orbit. After that, the Chinese launched Tiagong-2 in 2015, I believe, and they've sent one crew to it so far and actually did a spacewalk from it, which is another essential activity that they need to get experience with. But in mid-2016, Mission Control lost contact with the Tiagong-1, and so that removed the ability to actually bring it down in a controlled fashion, where they used the onboard thrusters to select where it was going to land. And hence, all of the news recently is it's out of control, it's going to come crashing back to Earth, and we don't know where, and we don't know exactly when. And the reason that we don't know exactly where is the green area is the path that the spacecraft covers. So it's from 42.8 degrees north latitude to 42.8 degrees south. This plot on the left shows the population density, and so most of the population of planet Earth exists from like here down to here, and then of course it depends on the longitude, how dense it's going to be. So right now, it could be coming down anywhere in that green area. We really don't know. As the time gets closer, and it gets closer and closer to the Earth, then, when we're within about a day, they should be able to say within 4 hours of when it's going to come down. But 4 hours is 2.5 orbits, so that still doesn't say exactly where you're going to be. And even if you're off by 45 minutes, you're on the other side of the planet. It's a 90-minute orbit. So it's sort of dicey to really predict these things. And you might ask why it's been so uncertain whether it was going to be December or January or now. And a lot of what goes into this is how active the sun is. When the sun is really active, lots of solar flares, lots of sun spots, there's a lot of ultraviolet radiation reaches the Earth, and that causes the atmosphere, the upper atmosphere, to heat up, and it sort of inflates like a balloon. The more atmosphere you have at the elevation of the spacecraft, then the more drag and the more rapidly it comes down. The sun has actually been very quiet for the last 6 months or more, and so that really affects the calculations of when it's coming in. There's also the problem that the spacecraft is tumbling. It's tumbling end over end once every 3 minutes, and that affects the drag on the spacecraft. So there's just lots of unknowns. But this is just another view of where all these orbital tracks are. So in the United States, the northernmost boundary is about the border between Wyoming and Montana, all the way across the country, and then it goes down into southern South America. In Africa, basically the entire continent is covered. Europe and Asia, it's sort of central Europe and Asia and south. So this is a plot of the observations and the predictions for how the altitude of the spacecraft is going to change. So back in December of 2017, we were at about 290 kilometer altitude, and it was slowly dropping here. And then the prediction was as it gets lower, you start getting a little bit more atmosphere, a little bit more drag, so the descent starts accelerating. And then when it gets in the final week or so, it starts really decelerating and dropping pretty quickly. So right now, we're at the point where it's dropping 10 100-ish kilometers a day. And once it gets to about 120 kilometers, then it's all over. There's no recovering from that, and it burns up in the atmosphere. And so this plot is the final let's see, where are we, 11? So this is about the last hour and 10 minutes or so. So it's descending. When it gets to about 100 kilometers, then boom, it comes in. So that's what we're expecting, and stay tuned for the final end game as time gets shorter. The refinement of the estimates will get better and better, and once they get within 12 hours, they should be able to say within about a 4-hour window, and that'll tell you, based on the orbital paths, that these are the parts of the Earth that it might hit. Everybody else is out of the woods. But so the one thing to keep in mind on this is, even though Denver is in the zone that the spacecraft is flying over at times, but the actual breakup of it happens fairly high, and based on past experience, the ground track of where the debris comes in that doesn't burn up might be 70, 80 kilometers in the width, and a couple thousand kilometers in the down track direction. And so it starts coming in. First thing is all the high drag stuff falls off and burns up, and then the spacecraft itself starts burning up because of the atmospheric friction. Pieces fall off. What is likely to survive the entry are things like pressurized or pressure vessels that, like oxygen and the propellants are in. Any rocket engines are very dense and protected against heat, so are good at high temperatures, so they'll likely survive. So the estimate is the spacecraft itself weighs about 19,000 pounds, and they expect about 10% of it will survive re-entry and actually hit the ground. And so, what does that really mean? And I wanted to look back even farther in history of one other example of this, and this was the Skylab spacecraft back in the 1970s. And this was, just like the Chinese had their first space station, this was America's first space station. It was basically the third stage of a Saturn V moon rocket, which they outfitted as a habitation module and a laboratory module. And there were 3 crews of 3 people each visited it. It launched in 1973, and over the course of the next year-ish, these 3 crews visited. The hope was that the space shuttle would be flying before this actually entered the atmosphere. And it turns out that the sun was fairly active back in the late 70s, and it came down a couple years sooner than what the original expectation was, and it came down in 1979. First space shuttle flight was in 1981, so that didn't happen. But same thing as that previous slide I showed you. It ended up spreading out over a couple thousand kilometers, and the way the debris pattern works is that the first stuff to fall off is the light stuff, the things that aren't very dense and that have a big surface area. So the solar panels, once the walls of the spacecraft itself rupture, then you get panels from the outside of the spacecraft. And then, ultimately it just fragments into lots of pieces. And the pieces then that make it the farthest are the high density pieces, the ones that have a lot of mass and that are smaller in terms of the cross-section area. And so they they were still in control of Skylab, but it didn't really have any onboard propulsion that it could use to drop itself out of orbit. It had thrusters which could orient it. And so they ended up trying to, when it was nearing its last orbit, they tried to tumble it so that would increase the drag and hopefully bring it down over the ocean. The intent was it was going to come down in the Indian Ocean. It actually made it to southwestern Australia. At least the debris did. And these are just, these are fairly awful pictures, but examples of some of the things that were found. This was a water tank, and this was part of another tank on the spacecraft. So all told, there was something like, I don't know, 8,000 pounds of debris was recovered. There certainly was a lot more survived. But the difference between these two is Skylab weighed something like 170,000 pounds, and the Tiagong is about 19,000 pounds. So Skylab was much, much bigger. Didn't kill anybody. Pieces were recovered, and we sort of expect the same thing's going to happen on or near April 1st. So yes, the sky is falling, but don't worry about it.